Welcome to our lesson on linear inequalities and systems of inequalities in two variables. Today we'll learn how to graph these inequalities and find their solutions. Let's start with the basics. A linear inequality in two variables is similar to a linear equation, but instead of an equals sign, we use inequality symbols like less than, greater than, less than or equal to, or greater than or equal to. For example, we might have y is less than 2x plus 3 or 3x plus 4. Y is greater than or equal to 12. Now, let's learn how to graph a linear inequality. The process involves three main steps. First, we graph the boundary line by treating the inequality as an equation. Second, we determine whether to use a solid or dashed line. And third, we shade the correct half plane. Let's start with a simple example. Y is less than x plus 2. Step 1. Let's graph the boundary line, y equals x plus 2. This is our boundary line, with slope 1 and y-intercept 2. Remember, the boundary line itself is the set of points where y equals x plus 2. Step 2. Since our inequality is y less than x plus 2, we use a dashed line to indicate that the boundary is not included in the solution. If we had y less than or equal to x plus 2, we would use a solid line instead. Step 3. Now we need to determine which half plane to shade. We can use a test point not on the line, such as the origin 0, 0, and see if it satisfies our inequality. Let's substitute x equals 0, and y equals 0 into our inequality. Y less than x plus 2 becomes 0 less than 0 plus 2, which simplifies to 0 less than 2. This is true. Since our test point satisfies the inequality, we shade the half plane containing this point, which is below our boundary line. Let's try another example. 2x plus 3y is greater than or equal to 6. First, we need to graph the boundary line 2x plus 3y equals 6. To make it easier to graph, let's solve for y. We get 3y equals negative 2x plus 6, so y equals negative 2/3 x plus 2. Now let's graph this inequality. First, we graph the boundary line, y equals negative 2/3 x plus 2. Since our inequality is greater than or equal to, we use a solid line because the boundary is included in the solution. Let's test a point, such as the origin 0, 0, in our inequality. We get 2 times 0 plus 3 times 0 is greater than or equal to 6, which simplifies to 0 is greater than or equal to 6. This is false. Since our test point does not satisfy the inequality, we shade the half plane on the opposite side, which is above our boundary line. Now let's see how to solve a system of linear inequalities. A system consists of two or more inequalities, and we need to find the region that satisfies all inequalities simultaneously. Let's solve the system. Y is less than x plus 2, and 2x plus 3y is greater than or equal to 6. To solve this system graphically, we graph each inequality on the same coordinate system and find the intersection of the shaded regions. The blue region represents y less than x plus 2. The green region represents 2x plus 3y greater than or equal to 6. The intersection of these regions, shown in darker color, represents the solution to our system. All points that satisfy both inequalities simultaneously. Linear inequalities have many real-world applications. For example, in business, they can represent constraints on production, budgeting, or resource allocation. Imagine a company that makes two products, product A and product B. They have constraints on production capacity, material availability, and labor hours. These constraints can be expressed as a system of linear inequalities, and the solution region represents all possible production combinations. In conclusion, linear inequalities in two variables represent half planes on a coordinate system. When graphing, we first draw the boundary line, determine if it's solid or dashed, and then shade the correct half plane. For systems of inequalities, we find the intersection of all half planes to determine the solution region. These concepts are fundamental in various fields like optimization, linear programming, and operations research. Thanks for watching.